So the first thing that we want to do is factor anything that we can factor. So this top part is a trinomial, and it looks like I can factor it. So I'm going to split that into two binomials. Since I have that minus at the back, that means I've got a plus and a minus. And then to get my x squared, I have x times x. And then I'm looking for two numbers that are going to multiply to make 4 that will also subtract to make 3, which would be 4 and 1, right? 4 times 1 is 4, 4 minus 1 is 3. And since my signs are different, I'm going to look and say, okay, I want this middle number to be a positive 3, so I'm going to put the 4 with the plus and the 1 with the minus. And then the bottom, I can't do anything with that, so x minus 1. So I see that I have a common factor between the top and the bottom, which is the x minus 1, which means that gives me a whole. All right, so I have a whole. I'm going to take that x minus 1 and I'm going to set it equal to 0. So if I solve for x, I get 1. So I have a whole when x equals 1. Now all I have left is x plus 4. So let's think about your vertical asymptotes. Vertical asymptotes come from the bottom, right? But you eliminated the bottom because of the whole. So therefore you don't have anything in the bottom, so there are no vertical asymptotes. So we'll just say none. And then horizontal asymptotes is where we compare the degree of the top and the degree of the bottom. So the degree of the top is 1, and on bottom you don't have anything, correct? Which means the degree is 0. So when the top degree is bigger than the bottom degree, then you don't have a horizontal asymptote either. And remember, you can refer back to that one part of the notes right there where it talks about your 3 options here. Okay, so if the degree of the top is bigger than the degree of the bottom, then you have no horizontal asymptote. Okay, so on to number 7. So if you look on top, you have a binomial, but you do have common factors, so we will take out a common factor. So I have 42 and I have 54. So the greatest common factor of 42 and 54 would be 2. And then if you look at your r's, you have an r squared on this term and an r to the first. You can always take out the smallest number of r's you have, so I can take out an r. And remember, when you factor something out, you're just dividing that out of those two terms. So 42r squared divided by 2r would give you 21r. And 54r divided by 2 is 27. So I have taken out that factor. And then on the bottom, I just have one term, so I can't do any factoring there. All right, we should have taken out a 6 up here instead of a 2. So that's going to change what's left over. All right, so 42 divided by 6 gives me 7, and then 54 divided by 6 gives me 9. Okay, so now I'm looking, though, and do you see how this has a variable with it, and the bottom has a variable with it? So actually, I can cancel out from top to bottom, and I can reduce these two as well. It really just doesn't matter, but I can actually take 6r from 48r, so I would have 7r plus 9 on top. 48 divided by 6 is 8, and then I canceled one of these r's, so I only have one r left. Anytime you cancel something with a variable, though, that gives you a whole. So I canceled an r, so if I set that equal to 0, that gives me 0, right? Now, technically you canceled 6r, but even if I set 6r equal to 0, I still get 0, right? I mean, the number really doesn't matter. It's all about the variable, okay? So if it doesn't have a plus or minus sign and you've canceled a variable, then it's just going to be that variable equal to 0, okay? All right, so on the bottom, we have an 8r left. So for your vertical asymptote, I'm going to take that 8r and set it equal to 0. If I divide by 8, r equals 0. So here's the thing. You have a vertical asymptote at 0. So if I actually thought about that on a graph, that would be here, right? Right there. And I also have a hole there, but if, let's say my graph looks like this, there's a hole right here. But don't I already have a hole there now because I have a vertical asymptote? So technically the hole and the vertical asymptote end up on the same line, so they kind of, you know, it's pointless to kind of list both, but we're going to anyways. All right, and your horizontal asymptote, we're going to compare the degrees of the top and the bottom. I usually do the original. On the last one I didn't, but I like to look at the original. So the degree on top is 2, and the degree on the bottom is 3. When the top is smaller than the bottom, then you have a horizontal asymptote at y equals 0. All right, so number 8, on top, we have 2 terms, and we do have a common factor between those 2 terms, which is 4. So I'm going to divide a 4 out of both of those. So if I take 4p and I divide that by 4, I'm left with p. And if I take negative 4 and divide that by 4, I'm left with negative 1. And then on the bottom, I have a trinomial, so I'm going to factor that. I have a plus in the back, which means I'm going to have 2 of whatever's in the front, so I have 2 minus signs, p and p. And I'm looking for 2 numbers that will multiply to make 4 and add to make 5. That would be 4 and 1. So if I look at this, I see I have a common factor. So I'm going to take and cancel that, and that's going to give me a whole. So I set that factor that I canceled equal to 0, and I solve for p. So I have a whole when p equals 1. All right, so what I have left is 4 over p minus 4. So when I think about my vertical asymptotes, I look at the bottom. I'm going to take that bottom that I have left over and set that equal to 0. So 4 minus p equals 0. So I have a vertical asymptote at p equals 4. And remember, this really represents x. All right, then think about your horizontal asymptote. Compare your degrees. The degree on top is 1. The degree on bottom is 2. When the top is smaller than the bottom, then your horizontal asymptote is y equals 0. All right, on number 9, I have a trinomial on top and a trinomial on bottom. So I'm going to go ahead and factor these. I have a plus in the back, which means 2 of what's in the front. Then I've got my a squared, so a and a. And I need 2 numbers that multiply to make 32 and add to make 12. That would be 8 and 4. 8 times 4 is 32, and 8 plus 4 is 12. Then I'm going to factor the bottom. Same thing, I have a plus at the back, so I look up front, 2 plus signs. A and A. Looking for 2 numbers that multiply to make 28 and add to make 11, which would be 7 and 4. Alright, so I'm going to look and see if I have anything to cancel from top to bottom. I have an a plus 4 and an a plus 4, so that's going to give me a whole. I'm going to set that factor equal to 0, so I have a whole at negative 4. So when x is negative 4, there's going to be a hole in my graph. So what I have left over is the a plus 8 on top and the a plus 7 on the bottom. So since I have something left on bottom, that means I do have a vertical asymptote. So I'm going to take that bottom and set it equal to 0. And honestly, you could probably just look at that and say that's going to be negative 7, right? So I have a vertical asymptote at a equals negative 7. And then compare your degrees. So on top, you have a degree of 2. On bottom, you have a degree of 2. When that happens, you need to take the numbers in front and divide them. So 1 divided by 1, which would just give you 1. So you have a horizontal asymptote at y equals 1.